The primary reason why you work with a database is so that you can easily work with data. That includes both ease of storing data and, more importantly, ease of retrieving data. Perhaps the most important issue with data retrieval is that you need to be sure that you can retrieve the exact data that is needed. In order to do that, you need some way to tell the database management system what data you want it to retrieve for you. Some of the problems that you run into when you work with a database are shown on this slide. It is entirely possible that the same data values appear in more than one row in a table, even though the data for each row may represent a different occurrence of the data. To get at just the exact data that you need some way to uniquely identify a specific row. Because we are working with relational databases when we work with SQL, we need some way to link or relate data that is in one table with data in another table. For example, this shows some columns that might be in a college course catalog table. You can see that there is a course ID, a professor name, the year the course was offered, and the semester. The course ID alone is not enough to identify a unique row in the table. There are 4 occurrences of the same course ID in this table. Combining the course ID and the professor is also not enough to uniquely identify a row. The same professor name is used for the same course IDs. Even adding the year to the course ID and professor does not help. It is true that by using the 3 columns, you can uniquely identify the first row, the course that was offered in 2017, but that doesn't help with the courses that were offered in 2018. Finally, by adding the semester to the other 3 columns, you can uniquely identify a row. This is just a simple example. In some tables, there may be many more columns where there could be duplicate data. You can imagine that the problem of uniquely identifying a row gets more complicated when there are more columns of duplicate data. What you saw on the previous slides was an example of a composite primary key. You saw how you had to keep going, adding more columns to the key to get to the point where you could uniquely identify a row. The term primary key is used to indicate the column, or in this case, composite columns, that are used to uniquely identify a row in a table. This is a very fundamental concept in a relational database. The primary key for a table lets you relate data in one table to data in another. It is one of the most important parts of defining a table. Composite primary keys have some problems. As you saw, you may have to keep combining columns until you get to a key that will give you the ability to uniquely identify a row. Some database management systems limit the number of columns that can be used in a composite key. The current version of MySQL allows up to 16 columns in a composite key, but some database management systems have a much lower limit, as few as 3. In any case, creating a composite key of more than a few columns quickly becomes very cumbersome. Using multiple columns as a primary key makes it much more difficult to create relations between tables. Finally, when you create a primary key, the database management system creates and maintains an index. An index is similar to an index in a book in that it is used by the DBMS to quickly locate rows. When you use composite keys, the DBMS has to write the composite key values to the index for each row that you insert. The longer the composite key is, the longer it will take to perform the insert. Similarly, when you retrieve data, the longer the composite key, the longer it takes to search through the index. Now, for many applications where the tables contain only a few thousand rows, you might not ever be able to detect the performance impact. But if you are designing a database that may grow to a large size or may have many simultaneous users, such as in a web application, you should keep in mind that database indexing is one of the factors that can affect performance of the application. So if composite primary keys are not such a good idea, what can you do? It turns out that relational database management systems provide another way to assign a primary key for a table. This is sometimes referred to as a meaningless key or a surrogate key. Meaningless means that the value that is used for the key does not have any meaning beyond providing a unique identifier for a row. For example, if you have a table of information about a person, one of the columns in that table might be the person's social security number. Your inclination would be to use the SSN as the primary key. In that case, the primary key would be created based on meaningful data. The problem with using meaningful data as the primary key is that the data might change, or in case of a SSN, the person might not give it to you. Because a primary key cannot be null capable, you don't have the option of not assigning a value to the primary key. So it is not a good idea to base a primary key on data that might change or that might not be provided. The term surrogate key simply means that the key value that is assigned to the primary key is a surrogate for or takes the place of any other values in the row that might have been used for the key. In other words, the surrogate key is used instead of a composite primary key. The actual terms meaningless key and surrogate key are not too important. You just need to know that you will see these terms used when referring to primary keys. In actual practice, you can configure a table to have a primary key that is generated by the DBMS when a row is inserted into the table. This type of automatic primary key is almost always a numeric integer value, and it is configured with the auto increment attribute. Auto increment means that when a new row is inserted, the DBMS gets the next sequence number and assigns it to the primary key. Most database management systems, including MySQL, let you specify the starting value for the auto increment primary key and the increment value. If you do not specify values, the starting value is 1 and the increment value is 1. We'll stick with those defaults in this course. Here we see an example of the course catalog table that we saw earlier. This time there is a primary key column named ID. When this table was defined, the ID column was defined as an integer, and the primary key and auto increment attributes were assigned to the column. That means that as new rows are added to the table, the next available sequence number is assigned to the ID column. The auto increment value is assigned on a per table basis. That means that if you have more than one table in a schema that uses auto increment primary keys, you might have the same numeric values assigned to the primary key columns. Two things. First of all, it is likely that all of your tables in a schema will have auto increment primary keys. The simplest way to create a primary key for a table is to designate an integer column as an auto increment primary key. Second, the fact that the same numeric value might appear for the ID in more than one table is not a problem. The value that appears in the ID is unique within the table. The fact that the same value occurs in another table has no impact on the value used in this table. You might be wondering why the ID numbers shown here are not in sequence. What happened here is that the rows were added to the database at different times. Some other course and professor was assigned ID 1055, and other courses were inserted after ID 2916, and before ID 3073. Again, the ID is meaningless data. Its only purpose is to let you uniquely identify a row. If you do need to assign a sequence number that has meaning, you should create a column that is not the primary key and use it for that purpose. Let the database manage the primary key. Don't try to outsmart the database management system. Having it manage the generation of auto-increment primary keys is of tremendous value. It makes it much easier to work with the relations in the database, and it gives you a way to get at the exact row or rows that you need to work with. This shows the columns for the city table. You can easily see that the ID column is assigned the primary key attribute. Because the AI is checked, this primary key is an auto-increment key. The database management system will now be responsible for generating a unique numeric value for each row that is inserted into this table. Finally, you can see an example of the auto-increment primary key as used in the city table. The key is shown under the ID column. As you can see, the value starts at 1 and is incremented by 1 for each row in the table. You can also see that the ID value has no particular meaning in terms of the data. The meaning is for the database management system, not for your application.